In the previous video, we built the first part of a netcat clone called rcat that could connect as a client to a netcat server. This time we're going to flip things around and start building the server side of the netcat clone, and we'll connect to it with netcat this time. So we'll start off in a similar way to last time. We need to build an address from the input. So we'll format host : port and format in the bind host and the port. And then rather than a TCP stream that we used last time, we need to use a TCP listener. And we'll bind rather than connect to the address. And we'll map the error to a string so that it can be output automatically from this function. So failed to bind to, and we'll format in the address we were trying to connect to and use a question mark to bubble that error up. Let's assign this to a variable. And then rather than the situation we had before where we were a TCP stream, we were just connecting to a server, there was just one of us doing one job, a TCP listener expects multiple clients to connect. So we get at those clients with the incoming function on the listener. And every time a new client connects to us, this will output a new value to us. You can think of it like an iterator. So we can loop through that, and the program will block while it's waiting for a new client to connect. And then you can see we're back to the type we were working with before, TCP stream. So that's the class that lets us read and write off the network. We'll match on that. And if we get a valid connection, we'll print out connection accepted. And if something goes wrong, we'll print out an error message. So this won't do anything much yet. We won't read or write from the stream when it connects, but we will at least see that this functions, that we're able to listen for connections coming in from clients, and that we can receive at least the connection, but not any data yet. So let's jump over to the terminal and see this in action. So in our first terminal window, we'll build and run the server. So you can see we get some warnings, but that's okay, we haven't finished coding yet. So in target debug rcat, serve on 127.0.0.1, so on localhost, on port 2323. So that should be listening. And then with our netcat client, we'll connect on localhost to 2323. And we don't see anything, but that's expected with netcat. And we can see for our server, we've accepted a connection. It won't do anything with it, but we're connected. So let's get back to the code and make sure we can send some data back and forth. So we want to fill in the OK branch of our match so that when a TCP client connects, we'll read the first bit of data it sends and print it out. We're not going to do this in the way we would in the final version of this program. I want to do it in a low-level way so we can see exactly what's happening. So the first thing we want to do is to try and read from the socket. So we'll take our TCP stream S and try to read from it. And that requires a buffer. So let's declare a buffer. So we'll make that a list of all zeros with 128 elements. So that is a 128 capacity or byte capacity array that we can read data into. And we'll pass that to our read. And that's telling us we can't read or can't borrow S as mutable. So we'll make that mutable. And then it will return to us the number of bytes we read from the network. So let's assign that to a variable. And we'll declare that separately. And then we need to handle the error here. So again, we'll just turn that into a string. Failed to read from socket. And we'll use the question mark to bubble that error up. So now we're saying try to read from the network, fill it into our buffer up to 128 bytes. If someone sends more than that, this will break. and then, or rather, it will fill that buffer and we won't read any more. So we won't consume the whole input, which is not a good idea, but shouldn't actually break. Rust should prevent that going wrong. And then it'll tell us how many bytes were actually read, so how much of that buffer got filled in on this loop. So now we will wait for some data to actually arrive, because until data arrives, this read will return 0 bytes read, while read bytes is 0. So now we'll wait until something actually arrives. Let's print out when we finally do receive something how many bytes we received. Received bytes, and we'll put in a format space and read bytes. And then we want to write out what we received to the console. So we'll put that out on standard out. Standard out.write, and we'll write out the part of the buffer that was filled in. So from 0 up to read bytes. So the rest of the buffer will still be filled in with zeros, assuming that the data that was sent was less than 128 bytes. Then we need to map error again to get rid of the error message. Failed to write to standard out. That's pretty unlikely. And then finally, just to make sure that this behaves as it should, we're going to flush standard out. So because we're only receiving a small amount of data, the terminal may choose to buffer, the program may choose to buffer, so we'll just do a flush. And we'll unwrap that. We don't really care about the error. That's not likely to fail. Let's give that a try. So let's build the new version of the project. We've still got some unused imports. I'll fix that in a minute. Then we can start up our server again on localhost, listening on port 2323. And we can start up netcat on localhost 2323, so we'll connect to the client. And then we can send something. Netcat client. And send. And then over in our terminal here, we've received 21 bytes that says, hello netcat client. So we'd like it that both the server and the client can do I/O, so they'd read and write over the socket while it's open. But for now, this has given us a working server that we can build on. We'll tackle the next step of this server and client in the next video, which will involve keeping the read and write streams open so that we can continue sending and receiving both on the client and on the server. I hope it was interesting to see, though, how this works at a low level, because we'll go on to using standard net tooling from the Rust standard library next time, rather than doing this directly. It's not something you do often, and it's certainly something that's problematic in most languages, like in C, where we've had endless issues with buffer overflows and other abuse of memory when trying to do this at a low level. Whereas with Rust, it keeps us relatively safe. It's just fiddly and complicated to write, and there's other people who've already written this stuff that we can just consume and build interesting programs from. So we'll get onto that next time.